This video presents examples of the independent t-test when assumptions aren't met. A researcher is studying the relationship between attitudes towards violence on TV and interest in the martial arts among adolescent boys. A random sample of boys who indicate their interest in martial arts as either high or low were also asked their opinion on the amount of violence on TV, using a scale from 1, not enough, to 4, too much. The independent variable is interest in the martial arts, and the dependent variable is attitude toward the amount of violence on TV. Here are the data. Let's check the assumptions. The first assumption is met. Each subject has either a high or low interest in martial arts, so the second assumption is also met. We do not know how the data were collected, but we'll assume that subjects were asked their opinions individually in a private setting, so that one individual's response would not influence another's. Now let's check the normality assumption. Attitude towards violence on TV is measured on a 4-point scale, so the data are ordinal. The fact that this researcher calculated means and standard deviations indicates nothing. A mean can be calculated on football jersey numbers, but that doesn't mean that it's appropriate to do so. This assumption has not been met. We stop here because the independent t-test is not appropriate for ordinal data. We don't need to check the last assumption because we cannot do the test. Researchers compared two interventions designed to help patients in their adjustment after joint replacement surgery. Subjects were randomly assigned to one of two interventions. The researchers believed that the new intervention would result in better adjustment than the standard intervention because of its greater emphasis on psychological and social factors. The independent variable is intervention, and the dependent variable is post-surgical adjustment, which includes physiological, psychological, and social factors. Here are the data. Results indicated that mean adjustment of patients in the new intervention was significantly higher than for those in the standard intervention. We aren't told what the significance level is, but they report p less than 0.05, so 0.05 is implied. Let's check the t-test assumptions. We don't know if this was a random sample, but if random sampling wasn't used, results may not be generalizable to all patients having joint replacement surgery. Subjects were randomly assigned to only one of the two interventions, so the samples are statistically independent. It's also safe to assume that subjects' adjustment scores are not related. The sample size is small, so the central limit theorem does not apply. Instead, we'll use SPSS to test both the normality and equal variance assumptions. The Shapiro-Wilk test is used to check normality for each level of the independent variable, and we are looking for p-values to be greater than 0.05. These are both greater than 0.05, so the assumption has been satisfied. The p-value for the Levine test is less than 0.05, so the equal variance assumption is not met. This means that we interpret the second row of output for the t-test results. The biggest difference between these rows is the degrees of freedom, which is determined differently for the separate variance procedure, and always rounded to the nearest integer. The standard error is also usually different for the two rows because they are calculated differently. A p-value of 0.000 only means that the value is very small. It does not mean that it is equal to 0. If you double-click on this cell, you'll see the real value. Because the researchers expected adjustment to be better for the new intervention, this is a one-tailed test, so we divide this in half to get the actual p-value. Very small values are generally reported as being less than some value such as 0.005. P is less than alpha, so the null hypothesis is rejected. This is how the results might have been reported. Because the null hypothesis was rejected, the researchers would use a follow-up one-tailed estimation procedure to estimate the size of this difference. A one-tailed test should be used with caution. A researcher should either be confident of the direction for the expected difference or the other direction should be of no interest. In this case, there was a sound reason for believing that the difference would favor the new intervention because of its focus on psychological and social adjustment, so a one-tailed test was appropriate. The independent t-test involves a comparison of means and is therefore not appropriate for ordinal data. We can check the normality assumption in SPSS using the Shapiro-Wilk test. If the equal variance assumption is not met, we use a separate variance procedure instead of the pooled variance procedure. SPSS provides results for both. The next video looks at effect size and one-tailed confidence intervals.